Welcome to the community of
engineers, the change agents in the society.
Continuation with the topic of torsion. Now we will solve some problems. Let us consider a hollow shaft of length 1.5 meter where inner diameter of the hollow shaft is 40 millimeter and the outer diameter is 60 millimeter. Now find the largest torque that can be applied so that the shearing stress does not exceed the value of 120 megapascal. Also find the tau minimum. Now to solve this problem, consider the torsion expression as T is equal to tau max upon Cj, where for J, for the case of hollow shaft, that is half pi C2 raised power 4 minus C1 raised power 4, and we have the values over 2 pi 30 millimeter raised power 4 minus 20 millimeter raised power 4. After solving this, we get the value of polar moment of inertia 1.02 to 10 raised power minus 6 meter 4. Now using these values in the expression, T is equal to tau max upon Cj, and tau max, that is 120 megapascal upon, in this case we will take the outer diameter, that is 30 millimeter radius, and 1.02 10 raised power minus 6 m raised power 4 is the polar moment of inertia. Now by solving this, we have the torque, that is 4.08 kilonewton meter. Now to calculate the second part, tau minimum, we will be using this expression. Tau minimum is equal to C1 upon C2 tau max. Now C1 is inner radius, that is 20 millimeter, upon the outer radius, that is 30 millimeter, and the tau max, that is 120 megapascal. Now after solving this, we have the value of tau minimum, that is 80 megapascal. Now let's see another problem. In this we have a shaft, multiple shafts. We have two solid shafts, in between we are having a hollow shaft, and the inner diameter of hollow shaft, that is BC shaft, this is known. The inner diameter, that is 90 millimeter, and the outer diameter is 120 millimeter. Now we have to find first the maximum and minimum shear stresses. The maximum and minimum shear stresses in shaft BC. Further, we have to find the diameters of shaft AB and CD, provided that the value of tau allowable is 65 megapascal. Now to solve this problem, we have select the shafts AB and BC for the equilibrium analysis. Now first we perform equilibrium analysis for shaft AB, and we take summation of moment about x-axis is 0. So starting from left, this is 6 kilonewton meter minus TAB is equal to 0. So we have TAB is equal to 6 kilonewton meter. Now for shaft BC, again taking moment, summation of moment about x-axis is equal to 0. So we have 6 kilo Newton meter. Again plus we have the value of this 14 kilonewton meter minus T BC equal to 0. So TBC is going to be, after solving this, 20 kilonewton meter. Now for the case of considering shaft BC, using the torsion expression as tau max is equal to T BC C2 upon J. Now to calculate the value of J, and this is a hollow shaft half pi C2 raised power 4 minus C1 raised power 4, so half pi, we have 60 millimeter per 4 minus 45 millimeter raised power 4. So we have the value of J, that is polar moment of inertia, 13.92 into 10 raised power minus 6 meter 4. Now using this value in the expression of elastic torsion formula, this is elastic torsion formula as T max is equal to, we have the value of torque, that is 6 kilonewton meter, multiply with outer diameter, that is 60 millimeter, upon the polar moment of inertia we have just calculated, this is 13.92 into 10 raised power minus 6 m raised power 4. Now after solving this, we have the value of tau max, that is 86.2 megapascal. Now we have calculated one of the value of tau max in the hollow shaft. Now to calculate tau minimum, we use this expression, the inner diameter upon the outer diameter, outer radius rather, we are using radius in this expression, and the tau max. Now the inner radius is 45 millimeter upon 60 millimeter, multiply with this 86.2 megapascal. Now after solving this, we get the value of tau minimum, which is 64.7 megapascal. Now the maximum value that is occurring here, and its value is 86.2 megapascal, and the minimum, that is 62.7 megapascal. Now we have calculated the tau max and tau minimum for the case of hollow shaft BC. Now further, to calculate the diameters for the shafts AC and BC, provided that the torque is given, that is 6 kilonewton meter, and tau allowable is 65 megapascal. Now to solve this, as we can say, the tau allowable is equal to tau max, which is equal to Tc upon J. Now here J is for the case of solid shaft. Now to calculate that J, we have the expression 1 upon 2 pi c raised power 4. Now this is the radius, and we have to calculate the suitable or the optimal radius for this. So we can use this value here in this expression. Now tau max is equal to Tc upon half pi c raised power 4, and further, after cancelling this, we can rewrite this expression as c raised power 3 is equal to 2t upon pi tau max. Now we know the values of this, so C3 is going to be 2, the value of T, that is 6 kilonewton meter upon pi, and the value of this tau max, that is 65 megapascal. Now after solving this, the c raised power 3 is going to be 58.8 into 10 raised power minus 6 meter cube. Now as we know that diameter is equal to the 2 radius, so 2 into 58.8 into 10 raised power minus 6 meter 3. So diameter is going to be 77.8 millimeter. Now with this we end our discussion here.